Hi everyone, let's start talking a little bit about hydronium and hydroxide ions and what they mean for the concentration of both acids and bases. So here's something interesting that we know. If we take water and we react it with itself, and that's kind of a weird thing to do, but once we do that, it's going to form H3O plus and OH minus. So basically one of the waters is going to accept a proton, therefore it's acting as a base. One of the waters is going to donate a proton, therefore it's acting as an acid. Here is our conjugate acid, here is our conjugate base. And so it turns out that experimentally we know the concentration of those two products. We know that the concentration of both H3O plus and OH minus is 1.0 times 10 to the minus 7 molar, and that happens at 25 degrees Celsius. But that allows us to do some really cool math for a whole variety of different compounds. So what we just saw is that if you have H3O plus and OH minus, which are the products of the self-ionization of water, aka water acting amphoterically as both an acid and a base and donating a proton from one water molecule to another, the concentration of H3O plus is 1 times 10 to the minus 7. The concentration of OH minus is 1 times 10 to the minus 7. And if you multiply those together, you get 1 times 10 to the minus 14th. We call that Kw. Kw is a constant. And so what this means is something really cool. It turns out that for any different substances, if we find the concentration of H3O plus, and by the way, H3O plus is often simplified just to H plus, so you take away water. So let's refer to H3O plus as just H plus. If you take the concentration of H plus and you multiply it times the concentration of OH minus, you always get the same number, Kw. You always get 1 times 10 to the minus 14th. Doesn't matter what you have in your mixture, you're always going to get that number 1 times 10 to the minus 14th. So we can use that mathematically. Now, how does that allow us to figure out whether we have a solution that's acidic, basic, or neutral? Well, once you do some math, if you realize that you have a concentration of H plus that's greater than OH minus, remember our definitions are that acids are proton donors, or they increase the concentration of H plus. So it makes sense that things that have more H plus are acidic. Whereas things that have more OH minus, if OH minus is greater than H plus, remember things that have OH minus we said are basic, so more OH minus means basic. And if it's neutral, then those two things are equal. But in every single case, if you multiply them together, they must equal the same thing. They must always equal 1 times 10 to the minus 14th. So let's try some practice problems. I'm going to join you on your note guide. Looking over at number 1, our job is the following. We need to figure out a few different things for each one of these problems. Our job is to determine the concentration of H plus. We need to figure out the concentration of OH minus. And we need to say, are these things acidic, basic, or neutral? So we're going to do those 3 jobs for every one of these problems. If you want to follow along for one and then pause, feel free. If you'd like to pause now and try it, feel free. But let's dive in and see what we have. So first off, in number 1, we are dealing with HCl, 1 times 10 to the negative 4th molar HCl. And if we're dealing with hydrochloric acid, and it's 1 times 10 to the negative 4th molar HCl, we said that this is a strong acid, and strong acids do something really, really cool. When they split completely. So we're going to form H plus and Cl minus. And it turns out that the concentration of both H plus and Cl minus, they are both 1 times 10 to the minus 4th moles per liter. So the first question here is actually an easy question. What is the concentration of H plus? Well, the concentration of H plus is given in the problem. It is 1 times 10 to the minus 4 molar. Voila. Let's do some work to find OH minus. So we know something, right? We know that no matter what we're dealing with, the concentration of H plus times the concentration of OH minus is always the same number. It's always 1 times 10 to the minus 14th power. If we know H plus, we can solve for OH minus. Let's do that, right? If we want to solve for OH minus, how are we going to get there? Well, we're going to take that 1 times 10 to the minus 14th power, and we're going to divide by the concentration of H plus. But the concentration of H plus is known, isn't it? You can see it right there in pink. So let's sub that in here. I'm going to erase concentration of H plus. I'm going to sub in my pink value. It is 1 times 10 to the minus 4 molar. And if you go ahead and you do that math, you're going to realize that the concentration of OH minus comes out to be, you might be able to predict what this is going to be, it's 1 times 10 to the minus 10th, right? And that makes sense because if you have exponents and you divide, you just subtract the exponents. So it makes sense that 14 minus 4 is 10. And so we have 1 times 10 to the negative 4th molar. So we've answered two parts of this question. We've answered both the concentration of H plus, we've answered the concentration of OH minus. All that's left is to say, is it acidic, basic, or neutral? And if you look, we have way more H plus than we have OH minus. So if we have a higher concentration of H plus, remember that means that we are dealing with an acidic situation. Let's slide on over to number 2. Let's do the same thing. So in number 2, we are dealing with a base, right? How do we know we're dealing with a base? Because it says calcium hydroxide. And there's a little trick going on in calcium hydroxide, right? So our first step was to do the concentration that's given in the problem. And so you might say, well, I can do that, right? I know that concentration of OH minus, that's going to match whatever the concentration of my calcium hydroxide is. It's just given in the problem. So I would say that's 1.0 times 10 to the minus 4 molar. And we have these really nice note guides that have the answers for you, and you realize that those two things don't match up, right? We have a problem. What the heck is going on there? It looks like we're halfway home. And the secret and why you have to be careful when you're doing these is as follows. So let's kind of erase and retry some of this. So it turns out that calcium hydroxide has a formula, and you probably know its formula. Calcium is Ca with a +2 charge. Hydroxide is OH minus 1. So what is calcium hydroxide? Well, it's CaOH2. So every single one of those calcium hydroxide molecules, or in this case really a formula unit, every single one of these has 2 hydroxides, which means we don't have this concentration. We have twice that concentration of hydroxide because for every 1 calcium hydroxide, we have 2 OHs. So that is why our concentration of OH minus is actually twice the given concentration. It's actually 2.0 times 10 to the minus 4 molar. Now the remainder of this problem becomes a bit more straightforward, right? We know some things based on what we saw before. We know that the concentration of H plus times the concentration of OH minus. Doesn't matter what we're dealing with, they're always the same number. They're always 1 times 10 to the minus 14. If we're looking for concentration of H plus, we can do some division, right? We know that concentration of H plus is going to be our 1 times 10 to the minus 14 over whatever our concentration of OH minus is. But we just solved for that, didn't we? It's sitting right there in pink. So let's sub that in, shall we? We're going to sub in our concentration of OH minus. It is 2.0 times 10 to the minus 4. And if you go ahead and you do that math, you're going to figure out that your concentration of H plus, make this blue, concentration of H plus turns out to be 5.0 times 10 to the minus 11. On our superscript trick doesn't work for the exponents here because one of our numbers is 1 and one of our numbers is 2. But regardless, we can figure out the concentration of H plus, and of course that is a molarity, moles per liter. So we're almost there. We've answered our concentration of H plus, we've answered our concentration of OH minus, and you can see if you zoom out here that your concentration of OH minus is much greater than your concentration of H plus. Therefore, you are dealing with something that is basic. All right, let's try a couple more. Again, if you want to pause and try on your own, feel free, or you can join us as we go through together. So number 3, hopefully you've got your eye out for the trick now. We're given a concentration, and in this case we're dealing with HNO3, we're dealing with nitric acid. Now nitric acid is monoprotic, so we don't have anything to worry about here. It turns out that 1.0 times 10 to the negative 3rd molar nitric acid, because it dissociates completely, it's a strong acid, means that the concentration of H plus is also 1.0 times 10 to the minus 3 molar. If we know that, then we can certainly come through and say that concentration of H plus times the concentration of OH minus is always the same number, 1 times 10 to the minus 14. We have concentration of H plus already, so if we want to solve for concentration of OH minus, that's going to involve taking our 1 times 10 to the minus 14 and dividing it by our concentration of H plus. And lo and behold, check it out, H plus is already given upstairs in red. So let's sub in for concentration of H plus what we already know to be true, which is that our concentration of H plus is 1.0 times 10 to the minus 3rd molar. If you do that math, you're going to realize that your concentration of OH minus turns out to be 1.0 times 10 to the minus 11 molar. And our last job is to say whether this is acidic, basic, or neutral. You'll notice that our concentration of H plus is much greater than OH minus. That means we are dealing with something that is acidic. Finally, let's slide over to number 4. Number 4 deals with sodium hydroxide. This one's given in words. Let's try to avoid the trick that happened before when we had 2 hydroxides. So sodium hydroxide is Na plus 1. It's bonded to OH minus 1, so it is simply NaOH. This is good news because you'll notice there's 1 OH for every 1 sodium hydroxide, so really the given concentration of 3.0 times 10 to the minus 2nd is also our given concentration of OH minus. That is just the same thing, 3.0 times 10 to the minus 2nd molar. We can also go through and figure out the concentration of OH minus, right? So we know that H plus times the concentration of OH minus is equal to the same number, 1 times 10 to the minus 14 all day long. We're looking now for concentration of H plus. So if we want concentration of H plus by itself, we're going to take that 1 times 10 to the minus 14. We'll divide by OH minus concentration. That's already been given in purple, so we can sub that in right here. That purple concentration was 3.0 times 10 to the minus 2nd. You should definitely try these in your calculator, make sure you're arriving at the correct answer, but when you do, our hope is that you figure out that the concentration of H plus ends up being 3.3 times 10 to the minus 13 molar. And if you compare your concentration of OH minus to your concentration of H plus, you'll notice that OH minus is much greater, so that means that we are dealing with a basic solution. Now, if you're pretty darn tired of writing out 1.0 times 10 to the 14th, and you're like, there's